Hello everyone, this is the demonstration of the shortest pathfinder project that I have made using Python, and this uses the logic of breadth first search. So first I have imported these modules, the turtle module, tkinter module. So the turtle module is here used here for the graphical interface. Then we need the numpy module, then the random module also we need. So first is the class bfs. So this class I have made to do all the bfs stuffs. That is first making the adjacency matrix. So this function this method is used to make the adjacency matrix. Then we have this calculate distance method. So this actually calculates the distance between the starting point and the ending point in the grid. So this is actually the method which is the most important method, the most important logic over here, that is which calculates the shortest distance. So then we have the main class body. So this is the init, too much of parameters. And then we have the main function. So in the main function we have initiated the bfs. We have created an instance of the bfs. Then we have made this adjacency matrix, and then we have done this calculate distance. If the distance can't be calculated, so it will show that there is no path found. Then we have the draw point. So this will basically draw the all the points, that is it will take the distance over here and it will draw all the points that will actually be graphically shown to the user. So here is the basically there are three types of things in that can be drawn on the grid. That is the starting point, the end point, and then we have the hurdles. So these are the functions that will activate and inactivate the operations. So this is the right. So this will just the pane object in the turtle is instantiated. So this will just write those particular things on the screen. These are the uh, kind of instructions for the users. Then we have this draw squares method. So the draw squares will take the x and y from the respective function call, and then it will just find out the x coordinate and the y coordinate where the square will actually be printed in the screen. So if it is hurdles, then it will print a red colored square. For start it will print a green color, and for end it will print a blue color. So this is the erase all function. So erase each and every type of hurdles or the start point or the end point, all will be erased. After that, this is the random hurdle method. So the random hurdle method, we just create 100 hurdles across the grid. Okay, so this is the mouse clicks. These are very much common to particular to the turtle object. Then we have this grid method. So the grid method will just create the grid actually, so where all these things will be simulated. So this is for creating that grid. And then we call the constructor of body. So this is the total program. So now we can run this to see what it happens. So here we can see, so a grid is created in front of us, and then there are some instructions. It says press S in the keyboard and click anywhere on the grid to place the starting point. So here we have the starting point. You can place it anywhere, just keep this here. Then press E in the keyboard. So E in the keyboard to place the ending point. So ending point, I want to place it like here. Then press H in the keyboard and click anywhere on the grid to place the hurdles. So I can place the hurdles at the particular positions that I want. So these are the positions that are blocked, so the path cannot go through these positions. Okay, so place more hurdles. So I don't want to place this manually too much, so I can just press R in the keyboard to place some random hurdles on the grid. So R will just create some random hurdles. So it will just place this randomly anywhere. So here we can see that some random hurdles are placed, and we can also create extra hurdles for actually getting a better simulation. Okay, so press space bar in the keyboard to see the shortest path. So here we can see that a shortest path is being created. So this is the starting points and end point, and this is the path that is generated. Okay, so now let me cover this path also by some hurdles like this, so we can see some another new, and I want to place even more number of hurdles, so by pressing R I can place that. Okay, that's quite a large number. So now let me press the space bar. So the path is being created, as you can see. Okay, so a new path is found between this point and this point, and eventually this is the shortest path, because we know that BFS always finds the shortest path, unlike DFS. DFS, it may or may not be the shortest, but for BFS it will always be the shortest path. Okay, so that's all for this program. So now let me place O. So O will actually totally erase everything, and now we can place this again from the beginning. So that's all for this project. Thank you for watching.